Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled RL Theory, Policies, Value Functions, and Q Learning, the basics of AI learning by trial and error. Imagine teaching a dog new tricks or a child how to ride a bike. They don't get a manual. They learn by trying things, getting feedback, a treat, a fall, and adjusting. This trial and error learning is exactly what reinforcement learning, RL, is for AI. Instead of being explicitly programmed for every scenario, an RL AI learns through experience to make the best decisions to achieve a goal. For developers, this means creating AI that can adapt and learn in complex environments, like games or robots, without us having to write endless if-then rules. In RL, we have two main characters, the agent and the environment. The agent is our AI program, the learner. The environment is the world the AI lives in and interacts with, like a video game level, a self-driving car's road, or a robot's room. The agent takes actions, like moving, jumping, or pressing a button. Within this environment, each action changes the state of the environment. E.g., your character moves from position A to B. As a developer, you'll define both the agent, your learning algorithm, and the environment, the rules of the world. How does the AI know if it's doing well? Through rewards. After the agent takes an action and moves to a new state, the environment gives it a reward. This can be positive, e.g., plus 10 points for reaching a goal, finding treasure, or negative, e.g., minus 5 points for hitting an obstacle, losing a life. The AI's ultimate goal is to maximize the total rewards it receives over time. Think of it like the score in a game. The AI wants the highest score possible, and these rewards guide its learning process. You, as the developer, design the reward system to encourage desired behaviors. A policy is essentially the AI's brawn or strategy. It's a set of rules or a function that tells the agent what action to take in any given state. Think of it like a strategy guide for a game. If I'm in state X, I should take action Y initially. The AI's policy might be random, but as it learns from rewards, it refines its policy to make better and better decisions. Our job as developers is to build an AI that can learn and improve its own policy, rather than us hardcoding every single decision. A value function helps the AI evaluate how good a particular state is, not just based on the immediate reward, but on the asterisk total future rewards it expects to get from that state onwards. It's like asking, if I'm at this point in the game, how many points do I expect to get from here until the end? This is crucial because an action might give a small immediate reward but lead to a much bigger reward later, or vice versa. Value functions allow the AI to think long-term, helping it avoid short-sighted decisions. Building on value functions, Q values take it a step further. A Q value tells the AI how good it is to take a specific action from a asterisk specific state. So, instead of just evaluating the state itself, it evaluates the state action pair. For example, if I'm in state A, how good is it to take action 1 versus how good is it to take action 2? The AI learns to associate Q values with different state action pairs. Higher Q values mean that action is expected to lead to more future rewards. This is often represented in a table called a Q table for simpler problems, mapping every state action pair to a value. Q learning is one of the most popular and foundational algorithms in reinforcement learning. It's the recipe the AI uses to asterisk learn those Q values we just discussed. Here's the magic. The AI starts by trying actions, often randomly at first, observes the immediate reward, and then updates its estimate of the Q value for that state action pair. It does this by looking ahead to the best Q value it could get from the asterisk next state. Over many trials, the Q values in its Q table gradually converge to reflect the true optimal values, teaching the AI the best action to take in every possible state without needing a model of the entire environment. For developers, Q learning provides a concrete method to implement a learning agent. So, how does it all fit? Our AI agent is in an environment, a state. It consults its policy, or its Q values learned through Q learning, to decide on an action. It takes the action, the environment changes to a new state, and it gives the agent a reward. The agent uses this reward and its updated understanding of value functions to refine its policy or update its Q values, making it smarter for next time. This continuous loop allows AI to learn complex behaviors. As a developer, understanding this loop empowers you to design, train, and deploy intelligent agents for games, automation, robotics, and more, where traditional programming falls short. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.